Right, so we've worked out our components, our x and y components, and now what we're going to do is find our resultants, the final solution that we're looking at. So as you can see, I've just prepared the graph again here, and I've just jotted down all the figures that we've worked out. So tug A, we worked out his x component was 75 and his y component was 0. Tug B, we worked out an x of 45 and a y of 21, and the totals that we get when we add the x's together and the y's together, we get 120 and 21. So how would this look on our graph? So what we're doing is adding these components up. So we've got our x component of 75. So let's say that comes to about there, 75. And then we've got a y component of 0, so it does nothing on the 0. Then we've got our tug B adding in 45 on top of that, and putting 21 in the opposite direction. So let's just call that one to there, 21. Okay, so we've got this now as our overall dimension, that x component, this y component. Okay, so there's nothing going through the centre of the graph now. So if we take that off there and produce a triangle from it, we're going to first of all follow our x. We'll follow this line, and this is of 120 in length. There's an arrow showing that's a magnitude. Okay, and then from the end of that, from the head of this, we're going to tap off in our y direction now, which is going up. And it's going up to a value of 21, so the length is set at 21. And then what we're going to be doing is joining these 2 points together. So we're going to go from the base of there to the top of there, join our arrow. So this is the positive direction we can go. We can see from where these arrows are going, the resultant is positive, pointing in this direction. Okay, it's not going in any other direction, because that would be going again, back here, it would be going against these forces. So how do we work out this value here? Well, there's a couple of ways you could do it. We could have done it with trigonometry, but that's a slightly long version, and we will use that again afterwards. But what we're going to do the easiest way is Pythagoras. Pythagoras' theorem says a squared plus b squared is equal to c squared. Really simple. Basically, c squared, or c, is the hypotenuse. Okay, the longest line, the one we want to see, which is again opposite our right angle there. The other two, it doesn't matter which way round you put it, so we can call this one A and this one B. So we can populate our formula now. We can say 120 squared plus 21 squared is equal to c squared. Now to work this out, 120 squared, on most calculators you should see a button that looks just like this, an x with a little 2. Okay, and all we do is we type in our 120 and then tap the x squared button, and it will give us our answer. If you haven't got an x squared button, don't worry. Very simply, 120 squared is just 120 times by 120. It's whatever number it is multiplied by itself. Okay, and that will give us our answer again. And in this case, 120 squared is 14400. So I'm going to write that here, 14400 plus, and 21 squared, done the same way, 21, hit the x squared button, is 441. Again, that's equal to c squared. So we can add these numbers together, and 144 and 441 is 14841. And again, that's still equal to c squared. Now, we need c on its own, not c squared. That's an irrelevantly large number to go in here. So all we do is I spin that round. I'm going to put that c on this side now. And the 14841, we're just going to produce a square root. And again, so on your calculator, you'll find there's a key that looks like that. And that will give us a square root. So see the square root of 14841, and the answer is, tap into your calculator, 121.82. So 121.82, and that is now this figure here. And what we'll do is we'll just round it up. Okay, so that's an 8 there, 122. And that value there is 122. So it's not a lot different from this line here, you'll notice. And as you can see, because this y component is quite short in comparison, then this line isn't going to be too far different. If y was quite large, then that'd be a huge line there, and this number would be a lot bigger. Okay, so it's quite small. And there we go. So we've got the magnitude. We've worked out what the joint pulling force of those two tugs are in this particular direction. And what we'll do is on the next clip we'll work out which direction the ship's going to go.